Tonight we're going to go through the review for our Chapter 7 test on projectile motion. So if we look at question number 1, it says a baseball is thrown horizontally with a speed of 30 meters per second, and at the exact same instant, a second ball is dropped. Which baseball hits the ground first? What we have to remember is that the horizontal motion of a projectile has nothing to do with how long it's going to take to hit the ground. So both balls are going to hit the ground at the same time. Question number 2 says a baseball player throws a ball horizontally. Which statement best describes the ball's motion after it's thrown? So we want to think about the horizontal motion as well as the vertical motion for our projectile. We need to remember that the horizontal velocity is a constant because it's not being affected by anything. But our vertical velocity is going to be increasing because our object is going to be accelerating due to the acceleration due to gravity. So when we look at our combinations, A is going to be our choice because the horizontal speed remains the same. There's nothing slowing it down or speeding it up in the horizontal direction. And the vertical speed will increase because it's accelerating due to gravity. Number 3, a red ball and a green ball are simultaneously thrown horizontally from the same height. The red ball has an initial speed of 40 meters per second, and the green ball has an initial speed of 20 meters per second. Compared to the time it takes for the red ball to reach the ground, the time it takes for the green ball to reach the ground will be, and again we have to think about the fact that it's the acceleration due to gravity that's going to determine the time, or the height that's going to determine the time, and since they're at the same height, it's going to take the same amount of time. Let's look at question number 4. Okay, question number 4 says a ball is thrown from ground level. What angle, as measured from the horizontal, will cause the ball to travel the further horizontal distance? So we need to remember the simulation that we did on the computer yesterday, and we talked about today in class. And we know that the horizontal distance, or the range, is going to be increasing as our angle increases until we get to 45 degrees. And then after that point, it's going to decrease its horizontal distance. So if we want the maximum distance, we want 45 degrees. Number 5, a ball is thrown from ground level at an angle of 30 degrees as measured from the horizontal, and is found to travel a horizontal distance of 50 meters. What other angle will cause the ball to travel the same horizontal distance? Well, again, what we want to think about is that complementary angles have the same horizontal distance. We know complementary angles are angles that add up to 90 degrees. So when we talk about 30 degrees, its complementary angle is going to be 60 degrees because 30 plus 60 equals 90. So 30 degrees and 90 degrees will give us the same horizontal distance, which happens to be 50 meters. For number 6, it says for the balls in number 5, which angle of throw will take the longest time for the ball to hit the ground? So our choices are 30 degrees or 60 degrees. And if we remember from our simulation yesterday, we know that as the angle increases, the time it takes for our projectile to hit the ground also increases. So the one that's going to be fired at the 60-degree angle will take a longer time. Now we've got our problems. And again, we just need to remember what our equations are. You'll be given the equations tomorrow like you were given on your quiz. You need to know what your conversion factors are, but you'll be given those as well. You want to make sure that you show all your work on your problems. So you're going to draw your diagram. You're going to label the horizontal velocity. You're going to label the vertical distance, which is sometimes referred to as y. You're going to label the horizontal distance, which is sometimes referred to as x. And then you're going to take the information that you're given and determine which equation is going to help you to solve for time. And then from there, you're going to take the time and solve for the variable that's missing in your diagram. So if we look at question number 1, it says, Billy the bowler rolls a ball off the edge of a 75-foot tall building at a speed of 12.5 meters per second. How far from the base of the building will the ball hit the street below? So we have to identify what information we're given. When it says that we've got a 75-foot tall building, that's giving us the vertical distance, or our y variable on our diagram. When we talk about that 12.5 meters per second, we want to recognize that as our horizontal velocity. So we'll put that on our diagram. When it asks how far from the base of the building will the ball hit, it's asking us for our horizontal distance, or our x value. Now when we do our problems, we have an issue of the fact that we're given 75 feet for our vertical distance, and we want to get that to meters. So to do a conversion, we look at the factors. It tells us that there's 3.28 feet per meter. So we set up our problem, and we find that there are 22.9 meters in 75 feet. Now we'll have the units in the right units so that we can use them in our problem. Our next step is always going to be to calculate the time. And we need to decide which time equation we want to use. In this case, because we're given the vertical distance, we can use our equation that gives us the vertical distance. And remember again, we could call vertical distance y if we look at an xy coordinate. So time equals the square root of 2dv over g, or we could say 2y over g. We're going to plug in 22.9 meters for our vertical distance. We're going to plug in 10 meters per second squared for g. We're going to take 2 times 22.9, divide it by 10, take the square root, and that's going to give us 2.14 seconds. So we know how long it's going to take our ball to hit the ground. Now we want to calculate how far away from the building it's going to hit the ground, or we want to calculate what our horizontal distance is. So our horizontal distance, or our x value, is going to be our horizontal velocity times our time. The problem gave us the horizontal velocity, so we're going to plug in 12.5 meters per second. We calculated the time to be 2.14 seconds. So 12.5 times 2.14 gives us 26.8 meters. Now let's look at our next problem. Okay, for this problem it says a plane flying 500 meters above the ground, that means that's our vertical distance or our y value, drops a huge canister containing packages to a village below. If the plane needs to drop the canister 0.85 miles before it flies over the village, so in other words, that's giving us the horizontal distance, how fast was the plane moving? So we do have to do a conversion before we can do our problem. We have 0.85 miles, which we want to get to meters. If we look back at the conversion factors, we know that there are 1,609 meters per mile. So 0.85 miles equals 13.68 meters. Okay, so our horizontal velocity is what we're trying to find. Our vertical distance, or our y value, is 500 meters. Our horizontal distance, or our x value, is 1,368 meters. So we have our picture done. Then we're going to figure out what equation to use, and we're going to have to use our equation that gives us our vertical distance or our y value. So we've got t equals the square root of 2 dv over g. We'll plug in 500 meters for our vertical distance or our y value. 10 meters per second squared for g. So 2 times 500 divided by 10, take the square root. It's going to take 10 seconds for our projectile to hit the ground. Then we can calculate the velocity. Velocity equals the distance divided by the time. Our horizontal distance, or our x value, is 1,368 meters. We're going to divide that by the 10 seconds it takes to travel that distance. And our horizontal velocity is 136.8 meters per second. All right, we look at question number 3. A ball rolls off a table at a speed of 1.45 feet per second. We're going to have to do a conversion there, but that's our horizontal velocity. Assuming it lands 135 centimeters from the base, that means that's our horizontal distance or our x value. We want to know how tall the table was. So that means we want to find the vertical distance or y. So we've got our picture, okay, our horizontal velocity, we're going to have to do a conversion for. We're given 1.45 feet per second. There are 3.28 feet per meter, so that equals 0.442 meters per second. Our horizontal distance, or our x value, was 135 centimeters. There are 100 centimeters in a meter, so 1.35 meters is our horizontal distance. Now we have all of our variables. We're trying to find our vertical distance, or our y value, how high the table is. So this time, to calculate time, we're going to have to use our equation. Time equals our horizontal distance divided by our horizontal velocity. We can't use the other equation because we don't know what the vertical distance is. So we'll plug in 1.35 meters for our horizontal distance, or x. We'll plug in 0.442 meters per second for our velocity, and we're going to get 3.05 seconds. Then we can figure out how tall the table was. We're going to take our vertical distance equals 1/2 gt squared. So we'll plug in 10 meters per second squared for g, 3.05 seconds for t. We'll square t, multiply it by 10, divide it by 2, and our vertical distance, or our y value, is 46.6 meters, which is a really tall table. If we look at number 4, okay, we're going to take our horizontal, or our vertical, a distance value of 5.5 feet and convert that to meters. So that's 1.68 meters, and we'll plug that into our diagram. Our vertical distance, or y, is 1.68 meters. Our horizontal distance, or x, is 345 meters, already in meters, so we don't have to convert it. And we're trying to find the horizontal velocity. Since we're given the vertical distance, we can use time equals the square root of 2 dv over g, or 2y over g. So we'll plug in 1.68 for our vertical distance, or our y value. We'll plug in 10 meters per second squared for our g value, and we get 0.579 seconds. Then to calculate our horizontal velocity, we're going to take our horizontal distance, or our x value, which is 345 meters. Sorry about that. And we're going to divide it by the time, which is 0.579 seconds. And that's going to give us 596 meters per second for our horizontal velocity. Okay, we've got our next problem. Okay, it tells us that the horizontal velocity is 3.5 meters per second. It tells us that the horizontal, or the vertical distance, or y, is 4.5 meters. And it tells us that the horizontal distance, or x, is what we're trying to find. So we'll use our time equals the square